Hey, good evening, Varsha. Good evening. Good evening, everybody. We have Sundaris and Tejaswini, Kalichalvi, Chandran, Varsha. Good evening, all of you. So today we will see, we are going to do problems from the 11th standard book, matrices and determinants. Okay, so we will work on, as usual, no? We will work on that multiple choice, which is at the end of the chapter. This chapter, exercise 7.5. So, I hope you all have the book. So, please keep the book open so we can work on those problems. Okay, I'll share my screen now. So matrices, unfortunately, it is not possible to type the matrix symbols. So I could not type. I'm going to only write down the problems. Okay. So problems, I think you people can see from the book yourself. So I don't have to write the problem, but I will just work on solving those problems. Okay. Okay. The first problem, um, I think more students are joining. Right. Okay, so let's get started. The first problem is if aij equal to half into 3i minus 2j. Okay, so then and matrix A is aij 2 cross 2 into 2. Okay, it's a 2 by 2 matrix uh, with the formula given for ai and ij. Okay, so then construct that matrix. Okay, so how can we construct this matrix? It's given that aij. Can you all see the board?
Yes, sir.
Okay, half into 3i minus 2j. Okay, so this is the formula. So now the way you construct the matrix is, like this. I, J, Aij. So A, it's given that it's a 2 by 2 matrix. So I varies from 1 to 2 and J varies from 1 to 2. So 1, 1, 1, 2, 2, 1, 2, 2 are the four elements of that matrix. So all we have to do is simply put I equal to 1 and J equal to 1 in the given expression for Aij, half into 3 minus 2. So that means this is half. So I'm simply putting I equal to 1, J equal to 1. Okay, so then now you put I equal to 1. So then it is, I can even write it down. I equal to 1 if you put half into 3 minus 4. So that means minus 1 into half is minus half. So this will be half into 3i, 3 into 2 minus 2j. Equal to 6 minus 2, 4. 4 into half is 2. 2, 2 is half into 3i. 3i minus 2j. Okay. So the matrix will be simply half minus half 2, 1. Okay. So which is option number half minus half 2, 1. Option number 2. Let's look at the next problem. It says 2x 2x plus what must be the matrix F if 2x plus this matrix 1, 2, 3, 4 is equal to 3, 8, 7, 2.
நான் போகும்போது அவங்க சம்மந்தி எல்லாம் வந்திருந்தாங்க. சம்மந்தி என்ன உடம்புக்கு என்ன
So matrix addition, we can operate it on both sides. So that means you can put 2x equal to, so you can subtract this matrix on both sides, just like you do in algebra. So this side, I am eliminating the matrix and moving it to the right side. So it becomes 3872 minus 1234. So what is this subtraction? Can somebody tell? You can tell, it's well and good. So matrix subtraction is take the difference of the corresponding terms. Matrix addition is take the sum of the corresponding terms, like that. 3 minus 1 is 2. 8 minus 2 is 6. 7 minus 3, 2 minus 4. So this is 2x. So then what is x? Half of this. So half of a matrix multiplied by this a scalar, half is a scalar number, right? Is each term should be divided by that scalar. So multiplied by that scalar. So half into 2, half into 6, half into 4, half into minus 2. So 1, 3, 2 comma minus 2. This is which of 1, 3, 2. Option number 1. Let's see. This is another problem. Go to the third problem now. Are you all following, right? The book, you hope you have the book in front of you where the problems are given. Okay. So 1, 0, 0, 0, 0, 0, 0, 0, 5. This I'm going to ask you because what type of matrix is this? Okay. So the options given are 1, is it a scalar matrix? Is this a scalar matrix? What
No,
is
sir.
Anybody?
No, sir.
This is not a scalar matrix because what is the characteristic of a scalar matrix? Yeah, the scalar matrix, for example, Solomon.
Sir, leading diagonal zeros irukadu, sir.
Okay. Leading diagonal will be all the 3 or whatever, all the numbers in the leading diagonals should be equal. Okay. So that means it is something into I. Okay. It should be some A into I. And the formula is the scalar matrix. I, I is having only the diagonals. Rest are all zeros. Okay. So this is your I. So you multiply I by any scalar number, like let us say A. You multiply it by A. Okay. So this is a scalar matrix AI. That will be A0, 0, 0, A0, A0, 0, A. So the scalar matrix will have everything else 0 and diagonals will be same, equal, all the elements in the diagonal. So this particular matrix is not having the diagonals as equal, so it is not a scalar matrix. Okay? Not a scalar matrix. Okay. What are the other options given? Is it a diagonal matrix? Is this a diagonal matrix? Diagonal matrix means only the diagonals will have values and the rest of the elements should be zeros. Okay, like this, all the other elements other than the diagonal should be 0. Then it is diagonal matrix. So diagonal can give any value. So that is your diagonal matrix. So this is a diagonal matrix. It is a diagonal matrix. Is it an upper triangular matrix? What is the definition of upper triangular matrix? Okay. So, if on one side, instead of the zeros on both sides, it's a diagonal matrix. If zeros is on either side, then depending on which side, it is either a upper diagonal or a lower diagonal matrix. Okay. So here, since everything is 0, it is upper. You can say it is an upper diagonal and a lower diagonal. So it is a lower diagonal matrix also. Okay. So what are the options given? The question is, which one of the following is not true? And 4 options are given. So which option will we choose now?
So first option, scalar matrix.
So option 1, it is not a scalar matrix. It is, rest of the options are true. Okay. Okay. Let's go to next problem. Okay. Now it is given that it's a very nice questions. Some of them look very easy, but it is very thought-provoking. Okay, so you need to it helps you to understand the types of matrices. So A plus B equal to AB. Okay, if this is a condition, what type of matrix is this? So the options given are A and B are 2 matrices not necessarily of the same order. Is this true?
No, sir.
Because if 2 matrices can be added, then they have to be of the same order. Okay. Otherwise, we cannot add 2 matrices which are of 2 different orders. Okay. So A and B must be of the same order. So A is not true. So A and B are square matrices of same order. Is that true?
Yes, sir. It's correct, sir.
Okay. Is it true that number of columns of A is equal to the number of rows of B?
Yes, sir.
Number of columns of, okay. So then A equal to B, is that true?
Not necessarily, sir.
Not necessarily. Okay, if A plus B equal to AB, then which option can we choose? I think A and B are square matrices. They have to be square matrices. Okay, because why they have to be square matrices? You tell me. Can somebody tell? Somebody said no. That is the option 2 is true.
Sir, because AB is possible, sir. Also, A plus B is possible, sir.
Right. So if A plus B and AB both are possible, then M should be equal to N. Okay. So they have to be square matrices and they have to have the same order because they can be added. So we'll go with this option 2. Even though number of columns of A is equal to number of rows of B, it is also true. So correct. If you want to choose multiple options, you can choose 2 and 3. Both are correct. Number of columns of A is definitely equal to the number of rows of B in this case. Okay, because they are both symmetric matrices of the same order. Okay. let's go to next problem. A equal to lambda 1 minus 1 minus lambda. Then what is the value of lambda? Then for what value of lambda, A square equal to 0 matrix? Okay. So for what value A square equal to 0? So we simply find out A square. Okay. Let's find out A square. So what is A? This is 4. I will write down this option 2 and 3. Number 5, A equal to lambda 1 minus 1 minus lambda. So what is A square? Let's find out A square. And if it has to be 0, then we can find out the value of lambda from there. Okay. Now find out A square. So lambda 1 minus 1 minus lambda. A square means you multiply it by A into A. Okay. So how do you multiply? The first, it has to be of the order. The first element is lambda into lambda 1 into plus 1 into minus 1. Okay. So that will be lambda square minus 1. This yes, first row, second element is given by product of first row and second column. So lambda into 1 plus lambda 1 into minus lambda. So that will be 0 because lambda minus lambda. This element is second row and first column. This is element number 2, 1 is second row into first column. So minus 1 into lambda plus minus lambda into minus 1. So that means minus lambda plus lambda. So this is again 0. Okay. And this element is again second row into second column. So minus 1 plus lambda square. Okay. So if this matrix has to be a 0 matrix, then what is the 0 matrix? 0 matrix means each and every element should be equal to 0. So we are already having 2 elements 0. Therefore here the condition is lambda square equal to minus 1 equal to 0. That means lambda square equal to 1 or lambda equal to plus or minus 1. Lambda is plus or minus 1 is which option? Option 2. Next problem. See, A equal to 1 minus 1, 2 minus 1, and B equal to A 1, B minus 1. Okay, so then, and A plus B whole square is equal to A square plus B square. Then the values of A and B are. So it's an exercise in adding, multiplying, simple matrix. This is a 2 by 2. This is a fairly simple matrix. So let's just do this. So A equal to 1 minus 1, 2 minus 1, and B equal to A 1, B minus 1. Now let's find out what is A plus B whole square. So the given condition is A plus B whole square equal to A square plus B square. So if these kind of problems, we cannot use algebraic identities. Okay, so they don't apply for matrices. Okay, so we have to check it out by taking each and every element. Like a plus b whole square, let us find out. For that, we have to find a plus b first. A plus b is add each and every term. Okay. So 1 plus a, 0. I'm adding 1 and a, minus 1 and 1, 2 and b, minus 1 and minus 1. This is a plus b. So a plus b whole square will be again you multiply by a plus b. A plus b is this. A plus b whole square will be so it will be 1 plus a into 1 plus a is 1 plus a whole square. Because other term is 0. 0 into 2 plus b. So that's why I simply put 1 plus a whole square. The next is first row into second column. So 1 plus a into 0, 0 into minus 2. So that is 0. Both are zeros. Okay. So this one, second row and first column, this will be 2 plus b into 1 plus a. Minus 2 into 2 plus b. Okay. And the last element will be 2 plus b into 0 plus minus 2 into minus 2, so that is 4. Okay, so this is what you get. Okay, we can simplify this a bit. 1 plus a whole square, I'll keep it as it is. 1 plus a whole square, 0. This one I will simplify. Okay, 2. I'll simplify it somewhere else and put it here. Okay, 2 plus 2a plus b plus ab minus 4 minus 2b. Okay, so where are the like terms? 2b and b. Okay, so that becomes minus b. So 2 and this becomes minus 2. So it is 2a plus ab minus b minus 2. Okay. So this is your a plus b whole square. Now let's find out a square. A square will be 1 minus 1, 2 minus 1. Into 1 minus 1, 2 minus 1. So it will be 1 minus 2. That is minus 1. This is minus 1 plus 1, 0. So this is 2 minus 2, 0. So this is plus 1, right, minus 2 plus 1. So this is your a square. So let's find out b square. B square is a1 b minus 1 so this is a square plus b. Okay, a into a, 1 into b. Next a minus 1. So this is ab minus b. This is b plus 1. So we determined a square, b square. Now let's find out a square plus b square. Equal to a square plus b minus 1, ab minus b plus 0, doesn't make any difference. So this is a minus 1, this is b. B plus 1 minus 1, b, a minus 1 plus 0, a minus 1. So now this is equal to the other thing, a plus b whole square that we got. Okay. So what? How can we solve this? So we can match the like terms, right? So a plus 1 and 0, okay, they have to be equal. So a minus 1, right? A minus 1 should be equal to 0 and b should be equal to 4. So only from these two terms we can solve it. So we can try to check the others. It will be true. But we can solve it only using these two values or these two conditions. So this means a equal to 1 and b equal to 4. A equal to 1, b equal to 4. That is your answer. Option 2. So we finished 5 problems, right? 6, we finished 6. Okay, we go to 7. 7th problem. So a is given, if a is equal to 1, 2, 2, 2, 1 minus 2, a to b. Okay, is a matrix satisfying the equation a into a transpose equal to 9i, where I is 3 by 3 identity matrix. Then the ordered pair a comma b is equal to. Okay. You all should try to solve these kind of problems as practice. So this gives good practice in matrix multiplication, matrix addition, subtraction, transpose, and all those functions. A is 1, 2, 2, 2, 1 minus 2, a to b. So what is A transpose? So the rows and columns get interchanged. So 1, 2, 2, you write, instead of 1, 2, 2 as a row, you write it as column. Second row becomes second column. So that means 2, 1 minus 2. A to B. And what is A into A transpose? The given condition is A into A transpose is equal to 9i. That means it is given as 9i means this. It's a scalar matrix. 9i. This is given. Now let's find out A transpose and equate it to this. So we get the value of A and B. Okay. So 1, 2, 2, 2, 1 minus 2, A to B into 1, 2, A, 1, 2, 2. Sorry. So let's multiply and put it down. So this is 1 square plus 2 square plus 2 square. So that means this is 9. So you see that is already matching. Okay. So first row, second column. So 1 into 2, 2 plus minus 4. That is 0. 2 plus 2, 4. 4 minus 4, 0. So we see that that is also matching with 9i. So first row, third column is a plus 4 plus 2b. Right? A plus 4 plus 2b. So this is equal to a. So that is one condition we have. Okay. But let's do some more steps in the multiplication. 2 into 1, 1 into 2. 2 into 1 is 2. 2 plus 2, 4. 4 minus 4, 0. So this matches with 9i. Second row, second column is 2 square plus 1 square plus minus 2 square. So that means 9. This also matches with the 9i. Second row, third column, 2a plus 2. 2a plus 2 minus 2b. அடுத்தது a plus 4 plus 2b. அடுத்தது 2a plus 2 minus 2b. அடுத்தது a square plus 4 plus b square. Okay. So now there are multiple equations that we can form by equating this matrix to 9i. Okay. So 4 values we see are already matching. The remaining 5 should match. So let us use a plus 4 plus 2b equal to 0. 2a plus 2 minus 2b equal to 0. As these two as the two conditions. Okay. You can choose any two conditions. Okay. So this I see that you simply add the two, we get 3a plus 6 equal to 0 because 2b minus 2b get cancelled. So that means 3a equal to minus 6, a equal to minus 2. Okay. So you substitute a equal to minus 2 in equation number 1. So what do you get? A plus 4 plus 2b equal to 0. That means 2b plus 2 equal to 0. To b equal to minus 2 or b equal to minus 1. So the required ordered pair is minus 2 comma minus 1. So option number 4, minus 2 minus 1. Okay. Now next problem I think doesn't involve much calculation. So see the problem. If A is a square matrix, then which of the following is not symmetric? A is a square matrix. Then is A plus T symmetric? You can check out using a small matrix. We can check it out. But those are given in your book. A plus A transpose is a symmetric matrix. Okay. And what about A minus A transpose? What type of matrix will that be? For any two matrices, 8, right? 8. So A plus A transpose is always symmetric. For any true matrices, A plus A transpose will be symmetric. What is symmetric? I'm talking about symmetricity, but symmetric means if there is a matrix, so what is the condition for this matrix, what I have written, to be symmetric? Can anybody tell? Symmetric means, okay, it should be the mirror image. Yeah. Tell me. Who's saying?
A equals to transpose.
Enema, can you repeat?
So a matrix should be symmetric if it is A transpose equal to A, sir.
Okay. A transpose is equal to A. Okay. So that means this element should be equal to this element. Okay. A21 equal to A12. A31 should be equal to A13. A32 equal to A23. Okay. So if these conditions are satisfied, the transpose will be equal to the matrix itself. Okay. So A plus A transpose will be in this nature. It will be symmetric. Okay. And what about A minus T? Will it be symmetric or not?
Sir, it is Q
Sir,
symmetric.
zero matrix, sir.
Yes. A minus T, A transpose is not symmetric, not zero also. Okay. It will be a skew symmetric matrix. And what is skew symmetric? Skew symmetric means, these terms, if they are equal, it is symmetric. If they are negative of each other, A21 is equal to minus A12, A31 equal to minus A13, and A32 equal to minus A23. And also, the diagonal element should be 0 for a matrix to be skew symmetric. Okay. So A minus A transpose is skew symmetric. And A transpose, A transpose will be symmetric. And A transpose A is also symmetric. Okay. So you can take a small matrix and check it out. Okay. So you will see that these are all always true. Okay. So then what option do we choose here? The given problem. So A plus B is A plus A transpose, which is not symmetric. So which are all symmetric and which is not symmetric? In the option 1 is A plus B. Fourth option. Because fourth option is skew symmetric. So A minus A transpose is not symmetric because it is skew symmetric. Okay. So option 4 is the answer. Okay. Problem number 9. A and B are symmetric matrices of order n, where A not equal to B. The two matrices are not equal. They are both symmetric and order is also same. Okay. A symmetric matrix has to be a square matrix. Okay. Now, A plus B is skew symmetric, A plus B is symmetric, A plus B is diagonal, A plus B is 0, which is true. Is A plus B, is it a skew matrix?
No, sir. A plus B is a symmetric, sir.
Right, right. Because based on the condition that we wrote before, if A is symmetric and B is symmetric, when you add, then these two terms, they will again become the mirror image terms will be equal, because in the first one it is equal, second one also it is equal. So when you add them, you're adding equal terms. So the sum will also be symmetric. So A plus B will be symmetric, okay, if A and B are symmetric. A plus, so it's given as A plus B is skew symmetric. So that is not true. So next is A plus B is symmetric. So that is true. Is A plus B diagonal matrix? No, not necessarily. Just because there are two symmetric matrices, the terms other than the diagonal, they need not be zero. So A plus B is not a zero matrix also. So what is the correct option here? A plus B is symmetric. Okay. Which option?
பையனுக்கு கல்யாணம் வச்சிருக்கோம். ஆமா, பெரியவனுக்கு.
Next, go to the next problem. If A equal to AXYA and XY equal to 1, then determinant of A transpose is equal to. Okay. Now it's given that A equal to AXYA. Okay. And it is, and we have to find out determinant of A transpose. So what is A transpose? AYXA. And determinant of A transpose. Let's do A transpose. First multiply the two matrices. A transpose. So this is going to be A square plus X square, AY plus AX, இதுவும் AY plus AX, இது A square plus Y square. And now we have to find out the determinant of this. So what is the determinant of this? This matrix. A square plus X square into A square plus Y square minus AY plus AX into AY plus AX. This is where A transpose. Okay. And it is given that XY equal to 1. Then now you have to find out A and B, right? No, you don't have to find out A and B. You just find out the value of A transpose determinant. Substitute XY equal to 1 and see what, get that value in terms of A. Let's see. This is A power 4 plus A square Y square plus A square X square plus X square Y square. is ay plus ax whole square. So a square y square plus a square x square minus 2 a square xy. So now is something getting cancelled? So you see that a square y square gets cancelled, a square x square gets cancelled. Okay. So now what remains now? A power 4 plus x square y square plus 2a square xy. Now it is given that xy equal to 1. Now you substitute xy equal to 1. What do you get? A power 4 plus 1 plus 2a square. So this is same as a square plus 1 whole square. So that is what it simplifies to, a square plus 1 plus whole square, which is option 2. Problem 11. Problem 11. The value of x for which the matrix A equal to e power x minus 2, e power 7 plus x, e power 2 plus x, e power 2x plus 3 is singular is. Matrix e power x minus 2, e power 7 plus x, e power 2 plus x, e power so so what does it mean if we say that this is singular matrix?
Determinant equal to 0, sir.
Correct. Okay. So that means this determinant is equal to 0. So let's evaluate the determinant. So it will be e power x minus 2 into e power 2x plus 3 minus e power 7 plus x into e power 2 plus x. So this is simply e power 3x plus 1 minus e power 9 plus 2x equal to 0. That means e power 3x plus 1 is equal to e power 9 plus 2x. So what can we conclude from this? So e power 3x plus 1 is equal to e power 9 plus 2x means 3x plus 1 has to be equal to 9 plus 2x. So solving this, what do you get? Subtract 2x from this side and 1 from that side, you get x equal to 8. This is your option 2. Okay. Now, here it is given that 3 points are collinear. Okay. Problem number 12. X comma minus 2, 5 comma 2, 8 comma 8. Okay. So these 3 points are collinear. Okay. So that means what is the value of x? So how can we say that? determine the value of x from this statement? Anybody?
Sir, matrix use பண்ணியா சார் இல்லாமையா சார்?
எப்படி வேணாலும் சொல்லலாம். I mean, just that you have to find out the value of x, assuming that these are collinear. Okay, you can take that. This is one, two-dimensional geometry use பண்ணி போடலாம் நீங்க. Okay.
சார் அது இந்த ரெண்டு பாயிண்ட வச்சு ஃபார்ம் பண்ணி
ரெண்டு பாயிண்ட வச்சு ஸ்லோப் கண்டுபிடிக்கலாம். இதுக்கான ஸ்லோப் ரெண்டு ஈக்குவேட் பண்ணி x கண்டுபிடிச்சிடலாம். That is one. Matrix யூஸ் பண்ணி எப்படி கண்டுபிடிக்கலாம்? Since you are in the matrix topics. For 3 points, matrix are determinants. If 3 points are given, what is the formula for area of triangle formed by 3 points? Good formula. If 3 points are of a triangle are given, so we can find out the area using a formula. Okay. And if they are the 3 points are collinear, then what will be the area of the triangle?
So the area would be 0, sir.
The area will be 0. So you put the formula for triangle and equate it to 0, and you can determine the value of x from that. So what is the formula for area? 1, 1, 1, x1, x2, x3, y1, y2, y3. This is the area of the matrix triangle. If any 3 vertices of a triangle are given, you put the first row as 1, 1, 1, and you put x1, x2, x3, y1, y2, y3, and determine the value of the determinant. So that will be the area of the triangle. But in this case, since the 3 points are collinear, it should be equal to 0. Okay. So we simply solve this determinant. So what is that determinant coming to? 5 8s are 40 minus 8 2s are 16. 40 minus 16 into 1. LMA 1 into 1 into we can ignore that. 40 minus 16 is 24 minus, okay, but 8x minus 16, 8x plus 16 plus 2x minus 10 minus 10, right? So upon solving this, what do you get? So minus 8x plus 2x is minus 6x. 24 minus 16, 8 plus 10, 18. So you can see that x equal to 3. So that is your answer, which is your option x equal to 3, option number 4. Okay, go to 13. It is given that determinant 2a x1 y1, 2b x2 y2, 2c x3 y3 is equal to abc divided by 2. Then area of the triangle whose vertices are blah blah blah, x1 by a, y1 by a, x2 by b, y2 by b, x3 by c, y3 by c. Just now we saw the formula for area of the triangle. Okay, so let's just do that. Okay. So the three coordinates are given as x1 by a1 comma y1 by what is this? x1 by a, y1 by a. அதே மாதிரி x2 by b, y2 by b, x3 by c, y3 by c. So if three coordinates are given or three vertices of triangle are given, area is equal to determinant 1, 1, 1, x1 by a, x2 by b, x3 by c, y1 by a, y2 by b, okay. So one thing we can do is try to solve this determinant, okay, by putting 1 into x2 y3 divided by bc minus x3 y2 blah blah. Okay, so we can do all that, but that is not necessary because in this given they are given that a similar determinant is given, and it's given that its value is abc by 2. So we have to try to get this in terms of the given determinant. What is the given determinant? Engage side. Given determinant is so we can use some properties of determinants to bring this determinant to this form. Okay, so that is what we are going to do. It is given that this is equal to abc by 2. Ipo, in the determinant, if you multiply, let us say one column, okay, if you multiply by a and then you can take out 1 by a. Okay, suppose you multiply by same as into a divided by a. Yeah, another is same as 1 by a into a x1 y1. Okay, I have taken out this 1 by a. Okay, so 1 by a into a is 1. Okay, 1 by a into x1 is x1 by a. 1 by a into y1 is y1 by a. Okay, so ஒரு காலத்துக்கு அது மாதிரி பண்ணலாம், ஒரு காலத்துக்கு ஒரு ரோக்கு வேணா அப்படி பண்ணலாம். இப்போ அதே மாதிரி செகண்ட் காலத்துல we can take out b. So then this will become b. For clarity purpose, I will write as 1 by b. Now we are taking out 1 by b. Okay. So it's 1 by b into b x2 y2 into 1 by c x3 y3 equal to, now we can write as 1 by abc. See, you see that, okay, I have written this matrix in one form and this is another form. X1, x2, x3 is a row work, is a column work. One property of determinant is that the value of determinant and its transpose is also equal to the determinant itself. The transpose panna, the value doesn't change. So we can write it as a இப்படி எழுதிக்கலாம் bc Okay. Now it is, the value is given for 2a, 2b, 2c. Yeah. So adnala, so what can we do now? Suppose this is 1 by abc is already there. Okay. So if you take out another half, then you can put it as 2a, 2b, 2c. Because half into 2a is a, half into 2b is b, half into 2c is c. So I'm not taking out anything from the other columns because they are already exactly as given in the problem. So this is equal to 1 by 2abc into, so what is the value of this determinant? It is given as it is equal to abc by 2. Now we can substitute this is equal to abc by 2 because it is given like that. So that means this will be 1 by 4. Okay. 1 by 4, which is your option 1. Okay. Okay. 13 we have finished, right? We go to 14. We'll do a couple of more problems and stop. Okay. If the square of the matrix alpha, beta, gamma minus alpha is the unit matrix of order 2, then alpha, beta, gamma should satisfy what relation? Okay. So we can simply take the square of this matrix. Let's do that. Alpha, beta, gamma minus alpha. Let us square it. We're getting alpha square plus beta gamma. This is alpha beta minus alpha beta. So that is 0. So this is going to be 0. Okay. This one will be alpha gamma minus alpha gamma. This is 0. So this is also 0. This is also 0. And this one is going to be second row, second column. Alpha beta plus beta gamma plus alpha square. So this is what you get. So you see these two are equal. Alpha plus beta gamma, alpha square plus beta gamma. So these two, the other two are 0. So it is given as this is equal to 2i. Okay, unit is a unit matrix of order 2. Sorry, just I, unit matrix of order 2. This is the unit matrix of order 2. So you see that already this 0 and 0 are matching. So the condition is alpha square plus beta gamma should be equal to 1. So this is your condition. Okay. So is this condition given in the options? Alpha square plus beta gamma. Option 2, if you see, it gets given as 1 minus alpha square minus beta gamma is equal to 0. So it's the same thing. Okay, 1 equal to alpha square plus beta gamma. Option 2. Let's do one more problem and we will stop for today. Problem 15. If delta equal to ABC, XYZ, PQR, then KA, KB, KC, KX, KY, KZ, KP, KQ, KR. So this is an easy one. Can somebody say what it's equal to? Determinant A, B, C.
Sir, I think so. It's equal to K cube determinant.
Yes. Okay. So why is that? Okay. KA So you see, column you can take out every row. Okay, every row you take out a K. So this K cube into delta, which is option 4. Okay, K cube into delta. Okay, so it's time up now. Please, let's break here, and you can try to do the remaining problems yourself. Okay, and come for the next class. So we'll continue with this, and there won't be many tougher problems now. Actually, in JEE, problems may not come from your 11th book, because you have continuation of matrix in class 12. Okay, applications of matrices and determinants. So where there are more advanced problems based on this. But this is very important for you to understand very well, to be able to do those problems in the 12th class. Okay, the problems in JEE will mostly come from 12th class. Okay, but this is the basic knowledge, the foundation. So you have to be very thorough with these concepts that we talked about. Okay. So please be very revise your fundamentals. We will discuss in the next class. Okay. Okay. Thank you all. Yeah, bye.
Thank you, sir.
Thank you, sir.
Okay. Bye.